Now let's move to question 11. Question 11. Let's see. This number that is written on that sheet or piece of paper, Galal cuts the sheet two times. So he gets 3 numbers. What is the smallest sum? So I'm looking for the sum of the numbers, sum of the digits here, that he can get by adding these 3 numbers. So he cut this piece of paper in two places. So he had 3 numbers. Then he added those 3 numbers together, and we need to find the smallest sum that he can get by adding those 3 numbers together. Now let's see the options. The options A, B, C, D, and E, all of them have 4 digits. That means 4 digit, 4 digit, 4 digit, and so forth. Now, how to think about this question? If you make the cut here, you will have a huge number, more than 4 digits. So let's think about another way. Let's see. If you cut again here, again, can you see a huge number? 2, 4, 6 digits. So we can't cut here. Then let's move to make it smaller. 1, 2 cuts. So here I have a 4-digit number, then 3 digits and 3 digits. So I'm expecting, if I'm having 1972, to have a very small number. If you move your cut, you will have, for example, here you will have 2000 something with 2000. So that makes more than 5400 or 200. That's here. So if you move again to this side, again you will have 5000 along with 2000. That makes also a very huge number, more than the options that I have here. So the suitable cut will be here. Now let's add, they said, the smallest sum. And why I'm having here? Because 0 here. So it will reduce part of the sum. Another 0 here. That means it will reduce part of the sum. So let's add those 3 numbers together. I have 1972 plus the 2 small numbers here, 970 and 502. Let's add 2 plus 0 plus 2, 2. 7 plus 7 is 14. Now 10 and 19. Now 24 and 3. So 3,400. 2 plus 2, 4. 2 plus 2, 4. 7 plus 7, 14. 9 plus 1, 10. And this is 14. That makes 24. And this is 3. So the smallest sum that I can have from the 3 numbers resulted will be B, which is 3,444, which is the right answer. Moving to question 11. That's a really interesting question. Now let's see and let's focus on this question. Question 12. The map here beside shows 3 bus stations at point A, B, and C. I will explain on the map. They said that from A to the zoo to the port, moving back to A, this tour is 10 kilometers long. Similar to that, from point B, the bus station, to the park, to the zoo, going back to the point B, this is 12 kilometers long, and so forth for the from zoo to the port to the park, going back to the zoo, and from point C, port, park, then going back to C. Now let's see the question. How long is the shortest tour in kilometers from A, B, C going back to A? So normally, if this is like straight lines, I can just measure the distances and find out how much is the distance from A, B, C going back to A. But here I don't have. I have only some lines which they are not straight, so I can't measure. What I have to do? Simply, see here, I have the distance along this path. The distance along this path. Here's the same, and here is the same. So I have to do the following. I can add this to that. So I have the whole distance like this, moving like this, or moving like this, including the inner part. If I want to exclude this, I can add the 3 lengths of 3 trips here or tours, then exclude the inner dimension. So I will add 10 plus 12 plus 13, that makes 35 kilometers. Now exclude the 15 minus 15 kilometers, that will make 20 kilometers, which is B. So B is the right answer, which is the shortest tour that can be from A to B to C, moving back to A again. Let's move to question number 13. Question 13. Rima wants to start at the arrow, follow the line, and get out at the other arrow. So on this map, she wants to start at this black arrow here and go out or get out from the other side. Now, which piece is not possible to put in the middle here to replace the question mark to obtain that purpose? Now let's see options here, A, B, C, D, and D, and let's decide. Now option A, easily you can link this part here, and she easily can come without continuing the rest of the map. So here she can move out, so that gives me a right part. Let's see B. B, I have 2 straight lines here. I can do straight lines here. I can move and make her leave from the other side. That means B is a possible piece. C, I can see here in a different way. How? Now, C, if we use C as is, you will draw like this, you will draw like this, and the line here, and this part here. So, N, and she will leave. So, that might be the right answer. You have to check all of them. D, you have this part and this part. Again, this one is similar to C. Again, this part, the other part here, this part here, the other part on the other side here. So this part is enough to let her moving out, and there is another line from this side here moving to the other side like this. But if she started from here to move, she will move out. So this also might be another answer because it's not suitable. E is similar to B. Can you see straight lines? Let's remove this and show you on the map. Here, another option. 2 straight lines in E, 2 straight lines here, and the lines here again. So N, move, and out. So also this is possible. Now, which one I have to choose? C or D? This side here, I can see that this is repeated here. And I can see this in another way. I can flip it. I can flip it. That means if I flip C to the other side, I will have this here, the line here, here, and here. So she will come and she will leave. So this one can be a possible piece, while this one, if you flip it any other direction, you will have the same impossibility to be part of this map, and D will be the right answer. Let's move to the next question. Question 14. We have this diagram, shows 3 hexagons with numbers at their vertices. But some numbers, as you can see here, those are missing numbers. Those are invisible. Now, the sum, as written here inside each hexagon, is 30 based on adding the numbers on the vertices. Now, what's the number that can replace the question mark here on that vertex? Let's see, is it 3, 4, 5, 6, or 7? Now, they said that the sum is, so I do care about the sum and focus on the sum. Let's see the sum here. It's 30, 30, 30. Now let's add the numbers. This is 9, 10, 12. How much I need to reach 30? This is 18. So those together, 18. Moving to the other hexagon. 10, 19, and 23. How much to reach 30? 7. Now, they said that the sum is 30. So I have 1, I have 7, I have 18, and this one is the missing number. Let's add and subtract out of 30. So 1 and 7, 8. 8 plus 18, 26. 26 to reach 30, you need 4 more. So the number that can replace the question mark is 4. So B is the right answer. Moving to question 15. Question 15 now. We have those 3 rectangles. They have the same height, and the numbers written inside each rectangle is the area measured by squared centimeters. Now, the length of AB is 6 centimeters, as you can see here. Now we need to find the length of CD. How can we find CD? Let's see. They said, very important point, that they have the same height. That means that I can find the height using this rectangle here. So in the first rectangle, I have the area, I have the 1 dimension, and the height is missing. So 12 plus 18 equals 6 times the height. Let's call it h. So that makes 30 equals 6h. Now, from this equation, we can find out that h equals to, if you divide by 6, 5 centimeters. So I have 5 centimeters here, 5 centimeters here, 5 centimeters everywhere for the height. Now I need this dimension. I have the area again, I have the height, and the length CD is missing. So using the same criteria, we will add 18 plus 22 equals 2. The length CD times the height, which is 5. 18 plus 22 equals 40. 40 equals the length CD times 5. This is another equation because CD, this is a missing number, so I can easily divide by 5, divide by 5. So the length CD here, this is the segment here, 40 divided by 5, which is 8 centimeters, which is C is the right answer. So based on the information that any rectangle, its area equals length times width or times the height here, width times the height, that helped me to find the missing length, which is CD. Move to question 16. Question 16. This is a triangular pyramid which is built out of 10 identical balls as shown here. On the top, here, as you can see in this 3D shape. Now, each ball has one of the letters A, B, C, D. So, and E, we have those balls A, B, C, D, and E. There are 2 balls marked with each letter. So of each letter I have 2 balls. The picture shows here 3 sides view. So 1, 2, and 3 of that pyramid. What's the letter on the ball that has the question mark? So they said that I can see 2 balls marked with each letter. So let's imagine this 3D pyramid and this side. Here on the top, I have A, but this is not A. It's the same ball. It's the ball here on the top. So this is one A only, one ball marked with letter A. If you check the other line, which is the next part here, you can see the ball B. I can see it from 2 sides. Ball C, I can see it from 2 sides. And the ball E, I can see it from 2 sides. So this is one ball, one ball. At the last part or the bottom part of the pyramid, I can see E. So E, I saw E twice. C, I saw C twice. D, we saw D here at the corners. D twice. You saw this letter repeated 4 times, but it's each one or one at each corner. And B, definitely B here on the top and on the bottom. So the only letter that didn't appear is A. So E, A will be here, which is the ball that is in the middle at the bottom part of the pyramid. So it will not repeat. You cannot see it from anywhere, from any side view. They said that we have side views only, 1, 2, and 3. The bottom, we can't see it. So A, the only way to see ball A is from the bottom side, and it's not appeared here. So A is the right answer. A is the right answer. Moving to the next question, question 17. Question 17. Question 17 now, again, moving back to those white and gray. Let's read the question and see the request and follow the guidance. 17. Fahd had 4 white tokens here, and Saad had 4 gray tokens. So we have white and gray. They played a game in which they took turns to place one of their tokens to create two piles, as you can see in each option here. So, one token from Fahad against one token from Saad. 1, 1, 1, 1 until they have built those two piles. Now, Fahad placed his actually first token. Then that means we started with the white token. Then Saad will follow with his gray token and so forth. Which pair they could not create? Let's see, we need to play as they played, and we need to see which one is impossible to be created. Let's see. We said that we need to start with the white token. So white, gray, white, gray, white, gray, or white, gray, white, gray. So this one, let me repeat here again. We will play the same way. So white, gray, white, gray, white, gray, white, gray. So this is possible. Let's move to B. White, gray, white, gray, white, gray, white, gray. Possible. Moving to C. White, gray, white, gray, white, gray, white, gray. Also possible. Moving to next. White, gray, white, gray, white, gray, white, gray. Let's see E. White, gray, then how? Gray, gray. So this one is the option that those two piles are impossible to be created using the same conditions that is requested in the question. Let's move to question 18. Question 18, we can see here a lock, and let's see the story behind this. My little brother has a 4-digit bike lock with the digits from 0 to 9 on each part of the lock as shown. So it has 4 parts, 1, 2, 3, 4. Each one has numbers from or digits from 0 to 9. He started on the correct combination and turned each part the same amount in the same direction, and now the lock shows the combination 6, 3, 4, 8. So he started from a certain point, then he moved each one the same number of movements. Now, this is the number that he had reached, 6, 3, 4, 8. Which of the following cannot be the correct combination of my brother's lock? So we need to find what was the combination that he started until he reached 6, 3, 4, 8. Let's see possibilities here and decide. Now, since it was 6 or it was 8 and reached 6, you can add or subtract. You may have the same result, but we need to make sure that we are moving a certain or the same amount of movement in each part. So 6 to 8, so 2 movements. So let's see, 6 to 8, so I'm adding 2 here. So let's add 2. 6, 8, 3 plus 2, 5, 4 plus 2, 6, and 8 plus 2. Imagine 8 will move to the 9, then what comes after 9? The 0 again. We said digits are from 0 to 9. So this one is correct. Another one, 6 and 3. So the difference is 3. So let's see. 6 minus 3, 3. 3 minus 3, 0. 4 minus 3, 1. And 8 minus 3, 5. This one is also correct. Now, 6 to 4. Let's subtract 2. 6 minus 2, 4. 3 minus 2 must be 1. But it's 9 here. So this is not correct, but you must complete checking all options. Here, minus 5. 6 minus 5, 1. 3 minus 5. So 3, moving to 4, 2, 3 to 8, we will subtract. It will move to 2, then 1, then 0, then 9, then 8. Next, 4 minus 5. From 4, you will move to 3, 2, 1, 0, and 9. So I counted 5. Correct. And 8 minus 5, it's 3. So this option is also correct. Let's check the last one. 6. 6 minus 6, 0. 3 minus 6, 2, 1, 0. Then 9, 8, 7. I moved 6 movements. Now 4 minus 6, 3, 2, 1, 0. Then 9 and 8, which is correct. And the last one, 8 minus 6, 2. So all of those are correct except C. So C is the right answer. This one cannot be the correct combination of the lock. Moving to question 19. Question 19. There were 20 apples and 20 pears in a box. While randomly took 20 pieces of fruit from that box. Basil took the rest. So overall we have 40. So Wael randomly picked 20 pieces of fruit and Basil took the rest. Now, which of the following statements is always true? Wael got at least one pear. Is that always true? No. Why? Because when he picked randomly, he might not have any pear. B. Wael got as many apples as pears. Also, there is no guarantee. He picked randomly. He didn't count how many apples, how many pears. So, he may have apples more than pears or the opposite. No guarantee that he can have as many as apples as pears. Let's see. C. Wael got as many apples as Basil. Also, there is no guarantee. How can I tell that the number of apples they will have will be equal? This is random picking. And D, Wael got as many pears as Basil got apples. Let's think about this option. If Wael got pears, for example, 3, so this is pears, so apples will be the rest, which is 17, because we said he picked 20 pieces. While Basil, he will get apples here, 3, and the rest will be pears. The rest, we said the rest, which is another 20 pieces. So let's see. Wael got as many pears as Basil got as apples. Yes, this is always true. If you change the numbers here, you will find the same result. So this applied always. Wael got as many pears as Basil. This is same as C, which is impossible to be always true. So D is the only logical possible answer for this situation. And the last here now, the last question 20. Question 20. Let's see. There is a single train track between points X and Y. This is the track. The track is divided into 6 equal parts. 1, 2, 3, 4, 5, and 6. A train company wants one train to leave from X and one to leave from Y at the same time. So one train will leave from here, another train will leave from the other side from point Y. Daily they want, or the company wants this to be happened on daily basis. Now, moving with constant speed, it takes 180 minutes for a train to make a trip from X to Y. So the train moving from X to Y, it will take 180 minutes, and they said with a constant speed. While it will take 60 minutes for the train to move from Y to X in the opposite direction. They want to build a double track to avoid any crash. When they move in the opposite direction at the same straight track, there will be a crash. So to avoid that, they will make a double track to avoid that crash. Where should the double track be? Let's see options A, B, C, and D, and E. So let's see the minutes needed to make the trip and compare the speed here, or compare how long will it take from each train to move on the track. So here we have 180 minutes divided on the 6 equal parts. So each part moving from X to Y will take 30 minutes, while it will take only 10 minutes moving from Y to X. That means triple the time is needed from X to Y. From X to Y, triple the time. So let's move from X to Y. From X, each one part here, because triple the time, that means 1, 2, 3. This one is faster. So 1, 2, 3, while 1 here. From Y, it's faster. So 1, 2, 3. So from X will be here. Then when he starts to move here, there will be a crash. That means the double track will not be useful here. Let's see B. 1, 2, 3. 1, 2, 3. So in this line, they will not meet. They will move along the double track without having any problem. So this might be our correct answer. Let's see C. 1, 2, 3. 1, still moving here. 1, there will be a crash here. Let's see D. 1, 1, 2, 3. 1, there will be a crash here. And the last option, E. 1 here, 1, 2, 3. Definitely there will be a crash here. So B is the right track that has double track here in order to make between point X and point Y to avoid any crash of the trains moving at the same time as we said they. هلا لهون طلابنا الأعزاء رح نوقف بهاي الحصة ورح نبلش إن شاء الله السيشن القادم عند السؤال 21.